Good morning, everybody. How are you all? Hope you are doing great this morning. Today, we are going to talk about discrete probability distribution. So I'll share my computer screen with you. So this is a chapter on discrete random variables. Again, the word discrete means, as you will see, whole numbers. So you jump from x value, if x is a random variable, from 0 to 1, from 1 to 2. So discrete jumps. And random means we do not know beforehand what we will get. Okay. And variables is something that varies, a number that varies. So a random variable describes the outcomes of a statistical experiment in words. The values of a random variable can vary with each repetition of an experiment. So let me read that again. Random variable describes the outcomes, mean results of a statistical experiment in words. The values of a random variable can vary with each repetition of an experiment. What is an experiment? Such as if you're taking a six-sided die, which has got on each face one number. So it has got 1, 2, 3, up to 6. Okay, so there are 6 possibilities or 6 outcomes possible when you roll the die. Beforehand, you will not know. Before rolling the die, you will not know what number will land with face up. Okay, so but we know that there are 6 possibilities or 6 outcomes. Outcomes means results. Okay. So they say values of a random variable can vary with each repetition of experiment, such as when you roll the die, you can get 1, next time you can get 4, next time you can get 3. But we know we are jumping from 1 to 2, 2 to 3. These are all discrete jumps. Uppercase letters such as capital X or capital Y denote a random variable. Lowercase letters like small x or small y denote the value of a random variable. If x is a random variable, then capital X is written in words and small x is given as a number. For example, let x equal to number of heads you get when you toss 3 fair coins. The sample space of the toss of 3 fair coins is TTT, means all the coins, 3 tosses, they land with the tail face up. Then the next one is tail, head, head. First one tail, second one head, third one head. HTH, first one head, second one tail, and the third one head, and so forth. Okay, then X is equal to 0, 1, 2, 3. Okay, why 0, 1, 2, 3? Okay, because suppose you may be looking for number of heads. Okay, you can, and that is indeed the case. It may so happen in the first one, TTT, there is no head. X is equal to 0, small x is 0. In the second possibility, head is 2, 0, and then 2. In the third possibility, also head is 2. Okay. In the first, second, third, fourth one, head is 2. Third one, fifth one, HTT, head is 1. So X is 0, 1, 2, 3. Okay. Just give me a minute. So as I was saying, in the first instance, TTT, first outcome, you do not have any head. So X is equal to 0, small x. Okay. The small x being the number of heads. And in the second one, you have 2 heads. So X, small x is 2. Okay. So X is in words. How many number of heads do you have? Capital X. And small x is the number 0, 1, 2, and 3. Why do we stop at 3? Because look at the last possibilities. All three are heads. So small x is 3. Capital X in that case is number of heads equal to 3. Notice that for this example, the x values, small x values are countable outcomes, something that you can count. Because you can count the possible values that capital X, which is inwards, can take on, and the outcomes are random. Random means you do not know beforehand what results you will get. The x value, small x value are 0, 1, 2, 3. From 0, we jump to 1, from 1 to 2, 2 to 3. So capital X is a discrete random variable. Discrete means jump from 0 to 1, no decimal values in between. Okay. A discrete probability distribution function has two characteristics. Each probability is between 0 and 1. Probability of an event that cannot happen at all is 0. Probability of an event that can happen, definitely will happen, that probability is 1, inclusive. So it can be 0, it can be 1. Sum of the probabilities is 1. Okay. Suppose you toss a fair coin. Okay. You can either get a head or a tail. What is the probability of head in the long run? 1 out of 2. What is the probability of tail in the long run? 1 out of 2. So half plus half is 2 over 2, 1. The sum of the probabilities is equal to 1. A child psychologist is interested in the number of times a newborn baby's crying wakes his mother after midnight. For a random sample of 50 mothers, the following information was obtained. Let capital X equal to number of times per week a newborn baby's crying wakes its mother after midnight. For this example, because, okay, small x is 0, 1, 2, 3, 4, 5. Okay. Let P of x is probability that x takes on the value, P of small x probability that capital X takes on the value x. And this is x on x, capital X takes on the value 0, 1, 2, 3, 4, and 5. Okay. So the mother can wake up. 0 means not at all. 1 means 1 time, 2 means 2 times, and so forth. Okay. This is a discrete probability distribution. Why? Because all the probabilities are all the probabilities are between 0 and 1 inclusive, and the sum of the probabilities is equal to 1. Also notice individual probabilities are not negative. So it cannot be less than 0. It cannot be greater than 1. A hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. The capital X is the number of times a patient rings the nurse during a 12-hour shift. For this exercise, small x is 0, 1, 2, 3, 4, 5. Probability of x is equal to the probability that x takes on the value x. Why is this discrete probability function? What are the two reasons? Sum of the probabilities is 1. So look at the first one. X is 0, probability is 4 out of 50. X is 1, probability is 8 out of 50. X is 2, probability is 16 out of 50. Add them together out, all the probabilities, you'll get 4 plus 8 is, okay, so you continue, 0, 1, 2, x can take any value between 0, 1, 2, 3, 4, 5. So in the first column, you in the first table, you have from 0 to 2. Second table, first column, you have between 3 and 5. So all the individuals probabilities are listed. If you add all the individual probabilities, you get 4 plus 8, 12. 12 plus 16 is 28. I'm reading from table 4.3 on the left. So far I've been 28 out of 50. Next one I add 14 out of 50. 28 plus 14 is 42 out of 50. Then we add 6 out of 50 is 48 out of 50. And the last one is 50 out of 50. Sum of the probabilities is equal to 1. All the Probabilities are positive and they have values between 0 and 1 inclusive. Okay. Okay. How do you calculate the mean or expected value and standard deviation of a discrete probability distribution? The expected value is often referred to as the long-term average or mean. This means that over the long term of doing an experiment over and over, you would expect this average. The law of large numbers states that as the number of trials in a probability experiment increases, the difference between the theoretical probability of an event and the relative frequency approaches zero. The theoretical probability and the relative frequency get closer and closer together as you repeat the experiment over and over again. Theoretical probability and relative frequency, they become closer. So this is the law of large number. Repeat the experiment large number of times, probability of each individual event is almost equal to the theoretical probability of that event. When evaluating the long-term results of statistical experiments, we often want to know the average outcome. The long-term average is known as the mean or expected value of the experiment and is denoted by the Greek letter mu. In other words, after conducting many trials of an experiment, you would expect this average value. To find the expected value or long-term average mu, remember mu is the population mean, and why it is there? Because it's a Greek small m, and because it's a population characteristic, it's always indicated by a Greek symbol, which is mu. Simply multiply each value of the random variable by its probability and add the products. So here is an example. A man's soccer team plays soccer 0, 1, or 2 days a week. The probability that they play 0 days is 0.2. The probability that they play 1 day is 0.5. And the probability that they play 2 days is 0.3. Notice the sum of the probabilities is 0.2 plus 0.5 plus 0.3. I'm adding all the numbers in the second column of this table is equal to 1. Sum of the probabilities is equal to 1 and all the probabilities are between 0 and 1. Hence, this is a probability distribution. What they did in this case is they multiplied each value of small x with its corresponding probability and added the product together. So the first one, 0 times 0.2 is 0. Next one is 1 times 0.5 is 0.5. Next time is 2 times 0.3 is 0.6. If you add the products together, 0 plus 0.5 is 0.5 plus 0.6 is 1.1. This is the expected value or long-term average, okay, of the men's soccer team would on the average expect to play soccer 1.1 days per 1 week. The number 1.1 is a long-term average or expected value if the men's soccer team plays soccer week after week after week. We say mu is equal to 1.1. So message from here, the mean is equal to the expected value. Don't quit me halfway, okay? Because please stick around till the end of this presentation because I will give you some helpful hint, helpful tip. And I have solved all kinds of math problem in my channel, Math Science Topia. You can subscribe to the channel. Please subscribe to my channel by hitting the red subscribe button at the bottom right corner. Then you will have access to all kinds of math problems, stat problems solved just for you. Okay. So here is a list of x values and the corresponding probabilities. So you multiply each x value with its corresponding probability and add them together, add the products together. What is the product? Product of x small x values and the corresponding probabilities. For example, for the first row, x value is 0, probability is 4 out of 50. 0 multiplied by 4 out of 50 is equal to 0. Next one, next row, x value is 1. 1 times the probability 8 out of 50. The product is 1 multiplied by 8 out of 50 is 8 out of 50, and so forth. Once you add all the products, you get the expected value. Okay? So mu is the sum of the products of x times the corresponding probabilities. Okay. Some of these problems I've solved in my YouTube videos, which you can check under the statistics playlist. Okay. Okay. Here they tell you how to do it using the calculator. Okay. So maybe this one we can do with a calculator. Okay. First thing we have to know what is 4 divided by 50, because we have to express all the probabilities as decimal. Well, because the calculator does not take fraction. Okay. So the first one is 0.08 probability, 4 out of 50. Next one will be 0.16 out of 0.16, which is 8 out of 50. Next one is 16 out of 50, which is 0.32. Next one is 14 out of 50. 14 divided by 50 is equal to 0.28. Okay. Next one is 6 divided by 50, which I believe is 0.12. And the last one is 2 out of 50, which will be 0.04. So again, repeating, 4 out of 50, probability in decimal is 0.08, 8 out of 50 is 0.16, 16 out of 50 is 0.32, 14 out of 50 is 0.28, 6 out of 50 is 0.12, 2 out of 50 is 0.04. So you have to convert the probability values into decimal before you do anything with the calculator. Okay, I have a TI-84 calculator. So what I first do is clear the memories of the calculator. Second button, then the plus button on the bottom right corner on top of the enter button. So second button on the top left, then plus button on the bottom right corner on top of the enter button. And then number 4, second plus 4 gives you clear all list on the calculator screen. Hit enter, says done. What does it mean? It means the memory of the calculator has been cleared. Now press the stat button, which is in the second row of the calculator keys. I'm working with a TI-84. So stat button and then number 1, which is edit. Now you have the different list, L1, L2, L3. Your cursor, the black rectangle, is sitting on the first line in L1, where you are going to enter. In L1, you are going to enter the X values. So first type in 0 and then hit enter. Then 1 and hit enter. Then 2 and hit enter. Then 3 and hit enter. 4 and hit enter. 5 and hit enter. Then press the right cursor key after 5. After you're sitting on the next line in L1, after 5, nothing to enter anymore in L1. Therefore, you hit the right cursor key on the top right corner of the calculator. And you go to the first line in L2, where you are going to enter the decimal values of the probability, which is first is 0.08, next one is 0.16, next one is 0.32, next one is 0.28, next one is 0.12, next one is 0.04. Okay, so we have entered the x values, small x values in L1, the corresponding probability values in decimal in L2. Now we are ready to calculate the expected value. So we hit the stat button again. Then with the right cursor key on the on the top right corner, we move the cursor, which is now sitting on top of edit. With the right cursor key, move it on top of calc, which is the second entry, calc. Then number 1, which is 1 where stats. My list is L1. First line is always L1. My second line, frequency list. Remember, the relative frequency or probability has been entered in L2. So in the second line, I also want to put L2. But right now, it is empty. So I put the cursor next to the colon in the frequency list. That is the second line. And I have to insert an L2 over there. How do I do that? I press the second button on the top left corner. Then number 2, it becomes L2. L2 in line 2 because the frequency list is in L2. Then I go down to calculate and hit enter. The first line will be the mean, which is 2.32. Okay. And if you look down in the fourth line after the mean is the standard deviation of this distribution, which is 1.2238. What is the standard deviation? This is the average deviation of a number from the mean. Remember, the mean is 2.32 and the standard deviation is 1.2238. On the average, a number in this distribution, 0, 1, 2, 3, 4, 5, varies from the mean by 1.2238. Okay. This is explained over here. Also, I will provide a link to a YouTube video which shows how to do this calculation on your calculator. Okay. Now we are moving into binomial distribution. Again, bi means 2. Binomial means in this type of experiments, there are 2 possibilities or 2 outcomes. One is called a success, other is called a failure. That's why it is called binomial. What is a good example of that? It's when you toss the coin. Suppose you are looking for head. Head is your success. If the coin lands head face up, this is success. If the coin lands with tail face up, that's a failure. Success and failure. Failure is the opposite of success. And you also know in the long run, the probability of success is 1 out of 2 or 0.5. Okay, binomial distribution, okay, by 2 possibilities. Probability of success is constant from trial to trial, 0.5 in my example. Probability of failure is also 0.5. Okay. So what are the characteristics of binomial experiment? There are fixed number of trials. Trials is same as experiment. Think of trials as repetitions of an experiment. The letter N denotes the number of trials. There are only 2 possible outcomes called success and failure. For each trial, the letter small p denotes the probability of success on one trial, and Q denotes the probability of a failure on one trial. P plus Q is equal to 1, such as probability of head is 0.5, probability of tail is also 0.5, probability of success plus probability of failure in this case is 0.5 plus 0.5 is 1. The N trials are independent and are repeated using identical conditions. Because the N trials are independent, the outcome or result of one trial does not help in predicting the outcome of another trial. Another way of saying this is that for each individual trial, the probability P of a success and the probability Q of a failure remains the same. Think of tossing a coin 10 times. What you get in the first toss will not influence what you get on the second toss. Similarly, what you get on the second toss will not influence what you get on the third toss. So all these trials, trial in this case is tossing the coin, are independent of each other. Okay. The state health board is concerned about the amount of fruit available in school lunches. 48% of the schools in the state offer fruit in their lunches every day. This implies that 52% do not. What would be a success in this case? To offer fruit in lunch every day. That's success. Okay. 65% of our people pass the state diverse exam on the first try. Okay, 65% is the probability of success, or 0.65. What is the probability of failure? 0.35. Either you pass the exam or you do not pass. If you pass, it's success. If you do not pass, it's failure. Okay, so 2 possibilities. Sum of the probabilities is 0.65 plus 0.35 is 1. Therefore, this is a binomial problem. Okay. The outcomes of a binomial experiment fit a binomial probability distribution. The random variable x, capital X, is the number of successes obtained in the n independent trials. It is written an X, capital X, number of success in a binomial probability distribution or binomial experiment. A total number of trials is n, and small p is the probability of success in each trial. Read this as x is a random variable with a binomial distribution. The parameters, the properties of the distribution, probability distribution, are n and p. N is the number of distribution, p is the probability of success on each trial. Binomial probabilities can be found by using binomial distribution. Starting the probability question mathematically is the start. Okay. A fair coin is flipped 15 times. Each flip is independent. What is the probability of getting more than 10 heads? More than 10 heads means what? X, capital X can be, or small x. Let x is the number of heads in 15 flips of the fair coin. So x can take any value from 0 to 15. More than 10 means 11, 12, 13, 14, and 15. Okay. The probability of success is 0.5, probability of Q, okay, is 0.5. The number of trials is n equal to 15. Straight the probability and question mathematically. So what you want to find out, what is the probability that x, capital X, is greater than 10. Greater than 10 means it starts from 11, 12, 13, 14, and 15. You just do not stop at 11 probability. You find the probability of getting 11 heads, add them to probability of getting the 12 heads, add that to the probability of getting the 13 head, add that to the probability of getting a 14 head, add that to the probability of getting a 15 head. Okay. Okay, so how do you do it in the calculator? Okay, to calculate probability of x, binomial PDF in your calculator. To calculate px less equal to, you use binomial CDF. Okay. So let's do this particular problem. Okay. So you want to find out probability of uh, 11 plus 12, probability of getting x equal to 11 plus 12 plus 13 plus 14 plus 15. You start from 11 because you want more than 10 heads. 11, 12, 13, 14, 15. You stop at 15 because that's your maximum number of heads. You know the sum of the probabilities of all possibilities of x from 0 to 15 is total sum of the probabilities is 1. From that, you want to find out probability of x greater than 10, that is 11, 12, 13, 14, and 15. You have to think of it as the probability of the complement event. Complement event is x less than equal to 10. Now, in probability of a complement event is equal to 1 minus, okay? So probability of an event A is equal to 1 minus probability of complement event. In this case, 1, sum of all the probabilities. From that, you remove the probability of the complement event. That is, you're not interested from 0 to 10. So how will you do this problem? You first type 1 in your calculator. That's the sum of the probabilities minus the probability of the complement event. Complement is opposite of x greater than 10, which is 11, 12. You want 11, 12, 13, 14, and 15. So you want to find the probability of x equal to 11 plus 12 plus 13 plus 14 plus 15. So what is your complement event? 0 to 10. So from 1, which is the sum of the probabilities, you would remove the sum of the probability of the complement event, which is from 0 to 10. When you are using to find the probability of 0 to 10, you are adding all these probabilities starting with 0 to 10. You are going to use the binomial CDF function as given over here. So this problem will be done. Okay. Okay. More than 10 heads. So 1 minus second verse from the sum of the probabilities, I will subtract the probability of complements with events, which is from 0 to 10. When you are adding from 0 to 10, you are going to split. So 1 minus second button, then verse button in the third row, and you scroll down to binom CDF. You use binom CDF when you are adding, in this case, from 0 to 10. So binom CDF, when you see, when your cursor is lined up with B as in boy, binom CDF, you hit enter. Number of trials, you're tossing the coin 15 times. Your probability of success is 0.5, and you're adding from 0 to 10. The last X value is 10. So X value type 10, and then you paste, enter, and enter. And the answer for this is 0.0592. What does it mean? There is a 6% probability, 0.059, I approximated it to 0.06. There's a 6% probability that you will get more than 10 heads in a flip of coin 15 times. Okay. Okay. It has been stated that about 41% of adult workers have a high school diploma but do not pursue any further education. If 20 adult workers are randomly selected, n is 20, find the probability that at most 12 of them have a high school uh, diploma but do not pursue any further. So probability of success is 0.41 and n is 20. At most 12 means from 0 to 12. So you're going to use the binom CDF. Okay. So second verse, why CDF? Because you're going to go from 0 to 12. CDF, C stands for cumulative. You're adding from 0 up to 12. So scroll down second, then verse button, then scroll down to B as in boy, which is binom CDF. Hit enter. Here, number of trials is 20. Probability of success is 0.41. And you want to add up to 12. So your X value, which is the last value in your addition, from 0 to 12. So X value is 12. Paste, enter, and enter. And the answer is 0.973. Okay, 38. About 32% of students participate in a community volunteer program outside of school. If 30 students are selected at random, that means number of trials n is 30. Find the probability that at most X is less equal to 14 participate in a community. So second verse, at most means from 0 to 14. So you scroll down to binom CDF. So you get the hint that when you are adding from 0 up to a number, you're going to use binom CDF. Then you might ask, when am I using binom PDF? If you want to find the value of the probability at one particular value of X, then you use binom PDF. Otherwise, you use binom CDF to add from 0 up to a number. So you go down to B as in boy, which is binom CDF. Number of trials is 30. Probability of success is 0.32. And your X value, 14. Okay, you want to add from 0 to 14. You paste, go down on paste. Remember, when you are on paste, your cursor is flashing on paste, you have to hit enter twice. And the answer is 0.9695. The mean of a binomial distribution is given by as n times p. The standard deviation sigma is then given by sigma is square root of n times p times q. Okay. In 2013, Jeremy's Rama Art Supplies catalog, there are 560 pages. 8 of the pages have feature signature artist. Suppose we randomly select 100 pages, n equal to 100. Let X, the total number and the number of pages that feature signature artist. Okay. Okay, what values does X take on from 0 to 8? What is the probability distribution? Okay. Find the following probabilities. Find the probability that 2 pages feature signature artist. Okay. So there are 560 pages, out of which 8 only feature signature artist. So what is the probability of featuring a signature artist? Is 8 divided by 560, which is 0.0142. 0.0142. That is your probability of success. Okay. Suppose we randomly sample 100 pages. N is equal to 100. Okay. Let X is the number of pages that feature signature artist. What is the probability distribution? Is a binomial, because either it will have a signature artist or no signature artist. Okay. Find the following probability. Probability that X is equal to 2. Okay. X is equal to 2. And randomly sample N is equal to 100. Okay. Find the probability of exactly X equal to 2. Okay. Remember, your probability of success is 0.0142, which is 8 out of 560. So second verse, and then you scroll down to exactly 2. That means binomial PDF. A as in apple. Okay. Number of trials is 100. Probability of success is 0.0142. X value exactly 2. Okay. Paste, enter, and enter. And the answer is 0.2457. At most, the part B, at most, means 0 to 6, binomial CDF. Second verse, scroll down to B as in boy. At most 6 means 0, 1, 2, 3, 4, 5, 6. Okay. Number of trials is 100. Probability of success is 0.0142. X value at most 6, 0 to 6 you're going to add. Paste, enter, and one more time enter. Answer is 0.9994. Probability that more than 3 means from 4 up until 100. So what is the complement of that? 0 to 3. More than 4, so more than 3 pages. So up to 4 to 100 you're interested. Complement is 0 to 3. So use the law of complement events. It's 1 minus probability 0 to 3. So 1 is the sum of the probability. From that you will subtract probability of the complement events, which is 0 to 3. Second verse, scroll down to B as in boy, which is binomial CDF. Enter. Number of trials is 100. Probability of success is 0.0142. And X value more than 3 pages means you're adding from 0 to 3 because it's complement of 4 and greater. Okay. So your X value is the last value which you're adding from 0, which is 3. 0, 1, 2, 3. Okay. And paste, enter, and enter. And the answer is 0.0547. Calculate the mean. Mean is n times p. Okay. What is your n? Is 100. Multiplied by, what is the probability of success? 0.0142. And the answer is 1.42. What is the standard deviation? How will you do? Is second x square, second button, and then x square, which is in the first left column of keys halfway down. That gives you the square root. Inside the square root, first you're going to type in n is 100 multiplied by 0.0142 and then multiplied by q. I have not calculated q. So what am I going to do? I'm going to put a left parenthesis. Then q is 1 minus probability of success, which is 1 minus 0.0142. Right parenthesis and hit enter. The standard deviation is 1.183. Again, repeating, the mean is easy to calculate, is n times p. 100 times probability of success. N is 100, p is 0.0142. If you multiply 100 times 0.0142, you'll get 1.42 as the answer. For standard deviation, you have to remember this is under the square root. So second button in the calculator, then x square button gives me the square root. Inside the square root, the first thing I type is 100 multiplied by small p, which is 0.0142, multiplied by left parenthesis 1 minus 0.0142, which is q. And then right parenthesis at the end and hit enter. Standard deviation is 1.183. Okay, so you can do these problems this way. So I stop here today. And if you have any question or comment, you can always write me a note. Okay. Let's do this problem. During the 2013 regular NBA season, DeAndre Jordan of the Los Angeles Clippers had the highest field goal completion rate in the league. DeAndre scored with 61.3% of the shots. So small p is 0.613 because 61.3 divided by 100 is 0.613. Suppose you chose a random sample of 80 shots, n equal to 80 shots, made by DeAndre during the 2013 season. Let x is the number of shots that scored points. What is the probability for x? Distribution for x? This is a binomial distribution because there are only two possible outcomes. Either you made the shot or you do not. Okay, so two outcomes possible. So it is a binomial distribution. Using formulas, calculate the mean. So n equal to 80 times the probability of success will be your mean. 80 multiplied by 0.613 is 49.04. What does it mean? In the long run, if you select random sample of 80 shots again and again, on the average, you will find out that DeAndre is successful in 49 shots out of 80 shots on the average, in the long run, out of 80 shots. Okay. Now we are going to go the standard deviation. So second button and x square button halfway down in first column on the left gives me the square root. Inside the square root, first thing is 80 multiplied by probability of success, which is 0.613, then again multiplied by left parenthesis 1 minus 0.613, because 1 minus 0.613 is the probability of failure or Q, and then hit enter. So the standard deviation is 4.356. Okay. Okay, let me go back to that problem. Find the probability, the last one, scored with 60 of these shots out of 80. Okay, 60 of these shots. So n is 80, probability of success is 0.613, and x is equal to 60. So it's a case of binomial PDF, not CDF. So second verse, scroll down to A as in apple, binomial PDF, hit enter. Number of trials is 80. Probability of success is 0.613. Okay. And you want x value exactly 60. So that's why I'm using binomial PDF. Paste, enter, and enter. That probability is 0.0035. Okay. Okay, 0.004. So 4 out of 1,000 chance. And find the probability that DeAndre scored with more than 50. That means 51 through 80. Okay. So the complement is 0 to 50. So 1 minus second verse. You scroll down to binomial CDF because you're using the complement event. Number of trials is 80. Probability of success is 0.613. And x value is you want to add up to 0 to 50, then you'll get more than 50. Okay, so 0 to 50 is the complement event, which you are subtracting from the sum of the probabilities of 1. So x value, the last value you're adding from 0 to 50. Last value is 50. Paste, enter, and enter. And the answer is 0.3718. Okay. So I stop here today. If you have any question or comment, write me a note. And if you like this video, please give me a thumbs up. If you like this video, share with your friends. You and your friends, please subscribe to my channel, Math Science Topia. Like I mentioned before, I have solved all kind of stats problem just for you. Okay. And do not forget to check me out because I'll come back tomorrow with another interesting problem, interesting solution. Thanks for watching. Have a nice day. Take care. See you next time.